Good afternoon, Antonio Pinder. I see your hand is up. Do you want to make a comment before we get started? Yes. Okay, great. All right, so it is 1 o'clock and we are back for our afternoon session of the Blue Economy Think Tank from the Bahamas Development Bank. I will turn it over to our moderator for the session, Mr. Carlos Palacios, to discuss maritime industry and energy. Mr. Palacios.
Thank you so much, Samaya. Good afternoon, everyone. I hope that you're all doing well. I see we have persons tuned in from all over the world. I know that it might be a little warmer or a little sunnier or a little colder or a little hotter, but either way, you are a part of the blue economy and you are learning with us and growing with us today. We'd just like to start by congratulating the outstanding team at the Bahamas Development Bank for organizing this wonderful panel, and to the previous panelists, moderators, and presenters for the amazing information that's been shared so far. So we welcome you this afternoon to the third session of the Blue Economy Think Tank. I'm Carlos Palacios, founder and managing principal of BRON, which is a multinational interdisciplinary development consulting group. And I'll be your moderator this afternoon. Our session is on the maritime industry and energy. And during this session, we will be focusing on opportunities within the sector, exploring mechanisms for ocean energy and storage, as well as discussing some new trends in the industry. So we want this session to be interactive. Please use the Q&A box at the top or bottom of your screen to ask questions throughout the webinar. We're also checking social media for audience questions. So please feel free to interact with us, and our esteemed panelists will be more than happy to provide the responses. I'm pleased to introduce our panelists. Joining us today are Captain Dwayne Hutchinson, who is the Managing Director and the CEO of the Bahamas Maritime Authority, Mr. Christopher Strawn, who is the Sustainable Energy Analyst at the Caribbean Development Bank, and Mark Legacy, who is an innovator in the energy sector. So we thank you all, to our panelists, for being here. And we'll begin with our panelists sharing their brief presentations on their respective topics. So at this time, we welcome Captain Hutchinson to present his respective discussion. Thank you.
Good day, everyone. And I'd like to thank the organizers for giving me the opportunity to make this presentation today on what is an important topic. I will attempt to share my screen, and I hope you can let me know when we're all on. So my name is Dwayne Hutchinson. I'm the Managing Director and CEO of the Bahamas Maritime Authority. And we are currently the 8th largest flag in the world. So that's something that the Bahamas can be proud of. But just before I begin, Mr. Moderator, can you just confirm you can see my screen?
Yes, we can see it. Thank you very much.
Okay, thank you. Yeah, just to carry on. So Dwayne Hutchinson, I've been in the maritime sector now for over 37, coming up to 37 years, including sailing at sea, and then in my current role working ashore with the Bahamas Maritime Authority. The purpose of my presentation today is just to run you through aspects of maritime from a regulatory perspective, because the Bahamas Maritime Authority has responsibility for managing the Bahamas ship registry, and equally we provide maritime advice to the Bahamas government. So the intent here is to just give you an overview of some factors relating to shipping from a regulatory perspective, and some food for thought for those of you thinking of entering what I believe is a very exciting industry. Blue economy. Shipping is very much a global industry. I mean, and it's said that 90% of world trade is carried by shipping, not shipping ships representing different type. As of 2020, based on the UNTAD, which is United Nations Convention for Trade and Development Maritime Report, there was about 98,000 ships, that's of globally of ships which are over 100 gross ton. The chart you see on the slide just gives you an indication of the scope of shipping globally. All the different colors represent different types of ships. And you will notice if you look to the bottom left where you have the United States in that broad area is the region of the Bahamas. But I think just looking at this picture, it shows you the scale of shipping and how it contributes to the logistic and the logistic chain for getting goods around the world. One thing I should highlight, and this is particularly came to the forefront during the current COVID pandemic, is that throughout the whole pandemic, shipping remained ongoing. There's aspect of the industry which, of course, was affected. That's the hospitality sector. Many of you know the cruise ship, but by and large, shipping was very much at the heart of the global response to, and will continue to be very much at the heart of supplying goods and services globally. And it's also said that, they say without shipping, 50% of the world would starve, and another 50% will go thirsty. So very much a broad part of this economy. I like showing this picture for every presentation I do, because people think blue economy in the Bahamas, and yes, you think, oh yeah, only the cruise ships, but this is only a small part of the maritime trade that allows that supplies the world economy in terms of goods and services. This year, as many of you know, is obviously Nassau Harbor, which is currently managed by Global Cruise Port, and I know it's under development, but that'll change. And I'm sure it's empty like that now. But I want to take you to a more broader picture of shipping in the sector. And this is more typical of what is the lifeblood of the industry. You have the different ship types from left to right, from cargo ships to right, which is tankers. So, it's goods that's carrying raw material in its form, right up to the oil tanker carrying liquid goods. And I also identified from an environmental perspective, the two ships you see right at the bottom are some interesting ships. One of them is a rig, so it's a ship that can obviously be sail in a normal ship mode, and then when it gets on location, it turns into what we call a jack-up. And the other ship that you see to the right is a ship which traditional ship, but what it's carrying is actually the turbines for wind farms. So very much shipping is diverse, and it certainly has the opportunity to continue to drive the world economy, both from a environmental perspective, but equally to ensure that all aspect of the economy is covered. Looking at the Bahamas and its role in shipping, this chart shows you the flow of traffic, mainly container traffic going within the Caribbean. And you will notice that the Bahamas is very much the hub of the trade, of this trade, because Freeport Container Port, which is one of the major container ports in the Caribbean, sits in the gateway between ships that are coming across from Europe and going to U.S. and South American ports, and equally ships that are moving to get to Asia, but going through the Suez Canal. And for what Freeport and Container Port does is gives us that transshipment hub. So the Bahamas is very much from what we call a port perspective, is very much at the heart of that transshipment route. And then from a coastal state perspective, the flow of traffic either going east or west would either come through Windward Passage or go up north of Grand Bahama, heading across Europe. So very much in the hub of how the transportation center works. But let me talk briefly about the regulatory framework and how we as the BMA certainly sits in. The Bahamas Maritime Authority, as I said, we represent the Bahamas government at the international forum that oversees the standards and regulations for ships. There are two principal groups that I will highlight, but as we're talking about the broader Bahamas, I'll also highlight another one. The first group is the International Maritime Organization, which is based in London, and they set out the standards for ships and the standards for ship construction, etc., and also for crewing. The International Labour Organization, which is in Switzerland, they do the labor standard for ships. And of course, you have the FAO, which is food and agriculture. That deals with the fishery aspect. But the key thing here is that those bodies set the international global standard upon which the Bahamas as a country would establish our national maritime laws. And then we would then apply that to all stakeholders. So any industry, any investor who's looking to move into the maritime sphere must be aware of the standards and guidelines that is coming from those bodies, because the Bahamas in adopting them will be applying them to the ships and the companies who are associated with the ships. So having that great awareness of the regulatory framework is critical. And the Bahamas plays a key role in the development and setting of those standards by our participation at those principally the two bodies that you see, which is the IMO and the ILO, but also working with the Department of Marine Resources. We've been engaged to some extent in the fishery aspect. In terms from the maritime regulation perspective, I just want to touch on what we call 4 pillars of maritime regulation. 1 is safety and security. 2, environment, which I believe is an area that's going to be covered. The third one is employment standards, and the last one is training. And all of those 4 areas are said to be the 4 pillars of maritime regulations, with different international regulations governing the standards to apply to ships and companies who operate those ships and equipment. And then based on that, the Bahamas and other governments will apply those standards, which means that the ships can trade globally. I highlighted some of the major conventions there. SOLAS, the safety of life at sea, that came out after the sinking of the Titanic, but that sets the safety standard. It also introduces security standards, which followed the 9/11 incident that led to more international maritime conventions for security on ships. Employment standard, that talks about the people trained on ship and how you treat them. So the Maritime Labor Convention. Training the personnel is covered by the what we call the International Convention on the Standard of Training Certification Watchkeeping, STCW. And of course, you have the environmental, the International Convention for the Prevention of Pollution on Ship, MARPOL. There's 6 annexes ranging from governing oil, garbage, sewage, noxious liquid substance, chemicals. So standards upon which anyone operating in the maritime sector would have to comply with. So when you're looking at maritime opportunities and investment, I think any stakeholder looking at the maritime sector should be aware that there is a regulatory compliance aspect and expectation of all stakeholders. And certainly, if you're expecting to be involved in engaging with any of those, some of those groups I mentioned, or ship type groups, the expectation of companies will be that you as a company comply with those standards, because you become an extension of those companies. There's also the consideration of looking at what is the acceptable standards for operation and processes. And again, they normally guided by the guidance and recommendations coming out of the main international bodies, the IMO, the ILO, which sets the industry global standards, but also there's a number of industry groups that utilize those standards, and where there's gaps, they develop guidance and recommendations for how to implement them. And I think as companies coming into the sector, the expectation is they'll be compliant. From a ship to shore interface, and again, not everyone will be dealing with the ships, and the expectation is that if you are investing in the servicing of the ships that are coming to the Bahamas or providing service to the companies operating out, you've got to be aware of the ship to shore interface. And a big part of investment, all investment opportunity is this broader approach, ensuring that you have an effective corporate governance. You know, you as a company, you as investors, stakeholders are currently asking, what are you doing? What are your policies around safety, security, environment, and personal protection? And the demonstration of that will normally feed in by showing your compliance with the international standards. And certainly from the BMA perspective, as the Bahamas Maritime Authority, we in interfacing with companies will be looking for those standards and ensuring those are in, issuing the appropriate certification and documents, so that that would be the evidence to show that as a shore-based company, companies covering it, you cover it. But so that's just a brief overview. I very much look forward for any questions or the following all the discussions. And you can certainly feel free to reach out to me. And thank you very much, Mr. Moderator, for giving the Bahamas Maritime the opportunity just to give that broad overview. Thank you.
Thank you so much, Captain Hutchinson. That was a very enlightening presentation. For so long, we've, I think, known in our heart that the trade and the ship industry is one that we have not truly tapped into as yet in the Bahamas. And so your presentation would have laid out so many different areas, from regulation to transshipment opportunities to stocking to just logistics that can allow us in our blue economy to grow and to mature into what we know is a large opportunity for us. So we thank you very much for that presentation. We are receiving questions already. Thank you very much to persons who are tuned in, and they are definitely going to be addressed as we go along. We just ask for you to be patient with us. Continue to send those questions in, as we will have our presenters bring their presentations, and then we'll get into the next steps, which will be for questions and answer. So thank you again, Captain Hutchinson, and we'll have you back for sure to answer some questions. Our next presenter is Christopher Strawn of the Sustainable Energy. He's a Sustainable Energy Analyst at the Caribbean Development Bank. We welcome Christopher now with his presentation.
Thank you very much, Carlos. Good afternoon to all the panelists and our attendees. I'm going to share my screen and let me know when you can see it. Apologies. Can you see it?
Not as yet, but we'll let you know when it comes up. It's coming up now.
Right. Thank you very much.
Thank you, Christopher.
So as Carlos said, I'm Christopher Strawn. I'm a Sustainable Energy Now Specialist at the Caribbean Development Bank. And I'm working with the Renewable Energy and Energy Efficiency Unit at the bank towards sustainable energy development in the region. Today, I will speak a bit about what we've done so far, looking at the blue economy, but especially as it pertains to marine renewable energy. But first, a bit of background on the bank itself. Which screen can you see? Can you see the one with the slideshow, or can you see the one with the notes as well?
We can see the one with the slideshow only. Okay. So that's good.
Thanks. So the Caribbean Development Bank is one of the smallest international financial institutions in the world, and the only dedicated IFI for the region. We have 28 members, 19 borrowing member countries, of which the Bahamas is one of them. and then 9 non-borrowing member countries. The purpose of the bank is to really improve the lives of the Caribbean people, and by doing so by contributing to the growth of our BMCs, as we call them, promoting regional economic and cooperation and integration. The key sectors that we are involved in primarily are infrastructure, as you would anticipate, so roads, bridges, ports, our own transport, energy, renewable energies and energy efficiencies, as I would have mentioned, social, education, agricultural, social protection, water and sanitation, and private sector development, particularly as it pertains to the support of micro, small, and medium enterprises. Now, as it pertains to the blue economy, the bank certainly recognizes the potential value that sustainable, inclusive, and equitable development this can bring to our borrower member countries. We've been working in support of the regional blue economy conversation through facilitating capacity strengthening and knowledge sharing workshops. For example, sponsorship of the Blue Economy Caribbean Day in 2018 and 2019. We've also been pursuing several studies, data gathering initiatives, promoting regional collaboration and cooperation, and publishing of various works to promote more informed decision making, such as assessments on renewable energy potential, as well as a publication in 2018 entitled Financing the Blue Economy, which can be downloaded from our website. As we can see from the figures here and from some of the presentations earlier today, the potential for economic growth and improvement of livelihoods through the blue economy is a massive one for our region. Some of the sectors and opportunities that we see that we're in the process of supporting and we see great potential growth in, as we would have seen, fisheries and aquaculture, marine tourism, coastal activities, marine renewable energy, so such as offshore wind, and then transport and shipping. In order to fully support these, institutions like the Caribbean Development Bank and others would need to provide certain support in certain areas. As we can see, when it pertains to marine renewable energy, we're looking at financing, promoting awareness, supporting the infrastructure that required to build out these types of developments, as well as supporting the development of supportive policies, enabling regulatory frameworks and legal frameworks, for example. Specifically, we have been doing some assessments on the most suitable technologies for the region, most relevant technologies. As you see here, we have 7 technologies ranked by their level of commercial readiness and suitability for the region. So we'd start with fixed offshore wind, which is where you have wind turbines that are attached to the seabed. Those would typically be deployed in shallower areas. Floating offshore wind is split into 2 types of floating offshore wind. You have conventional floating, which is more shallow, but also deeper than fixed, so 60 to 200 meters of water. And then deep floating offshore wind in depths 200 to 1,000 meters. And as you can see from the chart, blue indicates full-scale commercial rollout, green being pre-commercial, yellow is demonstration, and so on. So the technologies further down the list are more in the R&D prototype or demonstration scale versus the ones that are higher up the list. So fixed offshore wind is fully commercial. Floating offshore wind is getting to pre-commercial stage quite quickly. And then some of the other technologies are still under development. So we keep an eye on those ones for potential future deployment in the region. So we did a study in partnership with the Inter-American Development Bank, the IDB, in which we used geographic information mapping systems to plot the potential resource for various countries. So the objectives was to give an indication of what technologies could be deployed in certain areas or certain countries, and what the then theoretical or technically exploitable resource would be for each of those technologies. And then based on this initial output, we would select countries or potential areas for further, more detailed assessment. and feasibility studies. So the methodology, as I mentioned, was to utilize geographic information systems mapping data. We generated a series of maps, which gave an estimate of the potential renewable energy resource. As you can see here, it starts by plotting the exclusive economic zone of the countries, plotting setbacks from the land, and then applying certain layers, depths, wind resource, for example, and then exclusion zones such as marine protected areas and other excluded areas. And then based on the output of this, you would get an assessment of suitable areas that could be potentially developed for marine renewable energy technologies. So for the Bahamas, there's a series of maps we generated here that I can show. So here, this is for fixed offshore wind, and then the chart, the key of the chart, the greener areas are the most suitable, as it then changes from green to yellow to orange to red to show the least suitable areas. So for fixed offshore wind, we see a number of siting options. The largest is north of Freeport. Site southeast of Nassau may be most promising due to the proximity and demand and port infrastructure. Moving on to floating, conventional. So this is the more shallow water offshore wind. There are not as many suitable sites for the floating offshore wind, for this conventional floating offshore wind, because most of the better sites are shallow enough to deploy the fixed offshore wind, which, as you would imagine, would be better economics. For the deep floating offshore wind, they have a high scoring area east of Grand Bahama and a few other suitable areas for large scale projects, as you can see from the map. For ocean thermal energy conversion, there's a highly suitable area identified south of Freeport. However, this technology is the least mature. So this is one we would likely keep following the development of the technology, especially in the sizes that we would be looking at for the region, around the 10 megawatt size. And then having this information will be useful for future potential development. So in summary, you can see then that the Bahamas has very good potential for potential deployment of these technologies. So fixed offshore wind, floating offshore wind, and OTEC. And then here you get an estimate of the maximum technical exploitable resource for the various countries. So you would see then this first pass preliminary assessment shows the Bahamas has the highest potential exploitable resource compared to the 8 other countries that were assessed. Naturally, this potential will be significantly reduced as more constraints are introduced and with further feasibility studies. However, even if less than 1% of this potential is eventually realized, it can still meet or exceed the electrical demand currently. So by tapping into the marine renewable energy potential, many countries in the region could find themselves in a position of being net renewable energy exporters, for example, which is extremely encouraging. So the key findings from this preliminary assessment are that all the technologies have their own pros and cons, technology risks versus acceptability. There's plenty resource and space within the Caribbean for deployment of these technologies, especially the fixed and shallow floating offshore winds. It's been very useful to quantify what could potentially be possible, but we're going to need then to do further work, country-specific work, site-specific work to really assess what is the true feasibility for development of some of these sites. For example, the government of Barbados has taken this work 2 or 3 steps further, and they have done a very good country assessment showing the actual potential sites for development. So that's a roadmap that we would like to follow for many other countries. In order to develop the blue economy generally, but also as it pertains to marine renewable energy, we need certain enabling elements to be in place. CDB sees its role in supporting of these elements through financing for building awareness and promoting collaboration, cooperation, and strategizing at the regional level, supporting enabling legal and regulatory policies and frameworks, capacity strengthening and training activities across the board, supporting infrastructure improvements and resilience building, such as grid modernization, for example, de-risking of potential project development through project preparation work and studies to help reduce the costs of the resulting investment projects and ultimately the cost of electricity generated from such projects, and mobilizing special concessional resources to support inclusive, resilient development in this sector. In closing, we can see that Caribbean countries are taking the renewable energy transition very seriously. This is driven in many cases by more and more ambitious renewable energy targets and national determined contributions, the need to increase energy security as well as resilience. Marine renewable energy is the next logical space to deploy renewable energy, and in many cases may be necessary to achieve these targets of 100% renewable energy generation. The preliminary assessment indicates that there's massive potential for marine renewable energy technologies. Further assessments are underway by CDB, and we're going to likely go to market this year for consultant services to conduct follow-on detailed feasibility studies in countries with high potential, as well as seeking consultancy services and advisory services to strengthen our own internal capacity to support the development of marine renewable energy projects. So if you are aware of any firms that have that expertise, we can look out for our procurement notices on our website. In developing the blue economy and the marine renewable energy space, special consideration needs to be given to stakeholder engagement and effects on development on other marine users, geospatial planning, legal and regulatory frameworks, and especially environmental and social impacts. There are also challenges associated with scale, since individual project size will be well below the average size for typical marine renewable energy development. So what we may seek to do is develop regional clusters of projects that may be required to ensure economies of scale and also to attract developers, suppliers, or financing. Thank you very much, and I hope that gave a good overview of the state of play as we see it.
Thank you very much, Christopher. That was certainly an eye-opening presentation. I see the chat group is it's agitated, it's excited. People are saying, notice all of the potential of this area in the Caribbean and of course in the Bahamas. That was very encouraging. We appreciate your time and you presenting that very enlightening information.
Thank you.
Outstanding. We'll move to our third presenter for this afternoon, who is an innovator in the energy sector. Mr. Mark Legacy, please, the floor is now yours.
Good afternoon, everyone. Thank you very much to Ms. Cargile and to the Bahamian Development Bank and the team for inviting me to be a part of this distinguished panel today, and also to honorary ministers. Thank you for being here today, and distinguished audience members. We're here to discuss the possible futures ahead of us as we face a crisis with climate change and humanitarian and economic challenges. We are very aware of these. The blue economy is our focus today, but I would like to mention that we are pleased that our projects would qualify either directly or indirectly in all 6 of the colored economies, as well as we answer all 17 UN qualifications for the Sustainable Development Goals set by the UN member nation states in 2015. The universal call to action to end poverty, protect the planet, ensure that all people enjoy peace and prosperity by 2030 is our primary focus. Next slide, please. Ms. Bastian. Thank you, ma'am. So here is a visual of the structures and what they might look like in the future. These are in an ocean depth of anywhere from 10 to 70, 80 meters in ocean depth, sitting on the ocean floor. So before I get into all of that, I would just like to talk a little bit about me, my background. I grew up in a prominent Canadian engineering and construction family. We built bridges, dams, skyscrapers. We did government works projects. I did a lot of work in design and building in cement, steel, concrete, rock, advanced materials. I'm a master mason and a master smith. And as well as over the years, I've done extensive work in agriculture. And for the last 2 decades, worked as in Chinese medicine. But the engineering, or the sort of the question of answering the energy water food nexus, was always on my mind. And energy storage was what I saw as a solution to renewable energy becoming more guaranteed energy. So currently, we're surveying sites to build this innovative technology, which is patented electrical generation and storage and seawater desalination at a scale that allows export at a profit. And we are deeply committed to the principles and excited about making effective solutions a swift reality there in the Bahamas and around the world. Next slide, please. So what it is, and this is basically what you just saw on the exterior. This is what's going to go on the interior of the structure. Basically, there's an upper reservoir and a lower reservoir. And the ocean or lake or man-made lake is basically the existing water supply. So it acts as both the upper and the lower reservoir in the system within the structure. This can be built with enough power and water for a city, a state. And in the hydroelectric process here, reoxygenating the nearby marine habitats. So what we take out of the ocean goes back into the ocean and creates more habitat and also more ability for food creation. And the upper and outer surface on that structure can be used for residential, industrial, commercial purposes. We could apply a lot of different applications, supporting food security, even building a rocket port for one of Elon Musk's future deliveries to that area. Many applications can be applied. Now, the structure has a 100-year plus calculated lifespan, and that's due to ultra-high performance concrete, which is in the inside of the structure, and then a bioconcrete, or actually, in many ways, a bio-rock is on the exterior of the structure to help with marine habitat, and also specifically designed to that marine habitat or that species of fish or mammal that is living in that area. You can anticipate a much longer period with maintenance, mechanical retrofits, and so forth. And of course, all materials are recyclable, and we can sort of, like, nothing ends up as a landfill. One of the advantages is that with pump storage hydro, which is the basic technology, it is the best efficiency of all energy storage technologies today. So I can build both mobile to a micro solution to a utility scale solution. There are no end of life issues. The energy density, the reliability, the energy security it provides, it would allow for no more blackouts or brownouts, and no toxic emissions are created in the whole process. Every worker that is hired to build one of these structures, I'm going to need 7 ancillary workers to support that one worker. So this could be a major, major project for the Bahamas, and it creates increased habitat and sort of a living shoreline for the marine life as well as for us humans. Next slide, please. So what will it support? As we see here, the structure can be built very close to shore. So it would basically blend into any sort of coastal city. But its whole effect is that it would help with commerce, with health, with water, food export, general development, income, employment, tourism, manufacturing, the list goes on. And that's one of the reasons why it helps with so many different of the economies that we're looking to develop in the Bahamas. And if you could go to the next slide, please. And this is one of what would look like as a mobile application for disaster relief, for quick response, for the short-term answers to adapt, for small island nations to have both energy and water coupled with agriculture, coupled with solar and wind on a barge, albeit it looks like a oil and gas barge. It sort of is, but this is what it would basically look like. It's just we don't do anything with oil and gas inside. It's mostly agriculture, water, desalination, and energy storage. And that's what could be built for us in a mobile application. I've heard the saying, the Bahamas wants to become the breadbasket of the world. This technology would help achieve that. And with government approval, and of course, the help of the Bahamian people, we could reach this goal within 5 years. Next slide, please. And so this is one of sort of a scale structure to give an idea as to scale the patent. So in the photo, you can see a shipping container ship. In retrospect to the structures and how they can be connected by bridges out to ocean in order to deliver all water and energy from one structure to the next to the shore. Some numbers to give you guys to just quickly. I mean, a lot of the information I'm just going quickly over today. There is an abundance of different validations, proof of concept, different professors I've talked to. I'd be more than happy to answer all questions later. But today, for purposes, it costs roughly 3 to 5 million US per megawatt to build. And 5 million is probably because if we're doing a structure in an area remote, it's going to cost a little bit more. If we're building multiple structures in a production line, we can bring that cost down, of course. But it would generate that 1 megawatt, 4,380,000 kilowatt hours yearly, which could be a profit, a return on investment of $438,000 a year per megawatt. And that would have a return on investment in 11 to 12 years. But it also gives you energy, viable sustainability with no emissions. And it all comes from free energy from the wind and the sun powering the pumps to store the water. One of the things in which I designed the structure this way was I knew wind and solar had intermittent energy and did not have the energy density to desalinate water in the millions, if not billions of gallons. And so by going with hydropower, between the two reservoirs in the earlier picture, is an actual reverse osmosis desalination plant. And we use the height of the structure to help with the pressure. So current water prices today are usually quite high because most of the water has to go back to that coal plant or nuclear plant in order to cool it down. So a lot of the water is lost. And on average for a large plant, you're looking at 70 to maybe 90 cents per cubic meter of desalinated water. But that includes emissions. And then for small plants, you're looking at anywhere from $1.25 to $4.75, depending on the technology. And of course, again, it all depends on where your energy is coming from. With my system, we bring that cost down to roughly 25 to 30 cents per cubic meter, and with no emissions created. The power that could be generated for the Bahamas for sustainability. We could see a lowering from 21 cents per kilowatt hour right now without your fuel tax on top to roughly 12 to 13 cents per kilowatt hour. And again, with zero emissions. Your whole grid right now needs 500 megawatts for current sustainability. And that would be a cost of anywhere from 1.5 to 1.8 billion. And this would be your grid security for decades. You would have enough energy to even lower that cost, maybe even more, depending on where you're at in the sense of revenue. But when it comes to New Providence, just to give you an example, anywhere from 10, 50 megawatt to 100 megawatt structures to garner that full abundant energy independence. And that would go around the island, built in areas that are not in shipping lanes and not in sensitive marine environments. There's, like, as the Honorable Minister spoke earlier this morning, you have 46 times the area in the ocean, and I only need 3 to 4% of it in order to build what I call probably your biggest gold mine that you have, and that is being the energy storage for the United States of America. You have more than enough space to build 12 million megawatts of energy storage in the Bahama territory. And currently right now, the US uses 1.2 million megawatts for its electricity consumption, which equals out to about 4,600 terawatt hours a year. So I'm getting into some pretty big numbers here, and it can be a little bit overwhelming and especially completely unknown, because whoever thought of taking pump storage hydro and putting it in the ocean got a lot of laughter for a lot of years on that. But today, with all of the engineering and validation, these things have come along. Next slide, please. And so when I talk about the symbiotic relationship, as you can see in the background through the windows of the park here, this is between two of the structures in the bridge. And this is the human habitat in which apartments go around the structure, and inside is our symbiotic relationship. Below the waterline is marine habitat specifically designed for them, and energy and water production with no toxic emissions. I look forward to any and all questions. Thank you very much for inviting me here today and giving me the time to speak to you all. It is truly an honor.
Thank you very much, Mark. That is exciting, innovative, and captivating for sure. We appreciate you spending so much time and dedicating your life to bringing these solutions that hopefully will help to bring a lot of opportunity to small islands as well as the blue economy. Thank you so much for that.
You're welcome.
So we'll now go into our question section. We do have a number of questions. I thank you, panelists, for beginning to answer some of them in the chat. That was very helpful. We are obviously cognizant of the time, so we'll ask that you keep your responses to brief as possible, 2 to 3 minutes ideally, and we'll try to cover as much as we can in the last parts of our session. So we'll start with the first question to Christopher. Why should small island states like the Bahamas prioritize the blue economy and blue economy-based renewable energy? And how can this be done in an inclusive way?
Thanks, Carlos. So, I mean, as we've seen here today and probably have recognized for some time, the blue economy potential is really massive. So a more efficient, effective, sustainable, and inclusive development of the blue economy could have a tremendous positive impact on the economic growth of countries in the region. From a resource potential perspective, the potential benefits are significant, especially when it comes to renewable energy. All of CDB board member countries have committed to very ambitious national determined contributions to reduce our carbon footprint. Driven by this, as well as the need to reduce or stabilize energy costs, as well as to increase energy security and resilience, many have also indicated their intent to produce all of their energy from renewable energy sources in the future. So as such, considering the limitations, particularly the spatial limitations facing terrestrial utility scale renewable energy developments, the marine space is a logical option to help achieve these targets, especially when we look back at the resource potential. How can we do this in an inclusive way? I think that's really the role for the development banks, such as Bahama Development Bank, Caribbean Development Bank, and other development partners in the region who have a mandate and a focus on ensuring equity, ensuring stakeholder engagement, no harm to environment, those type of things. And we really need to ensure that we support the governments and the private sector and build awareness around why it's important that these are developed in a sustainable and inclusive way. So thank you.
Great, thank you for that, Christopher. Mark, how can energy production and storage become affordable and cost-effective by utilizing our biggest resource, the ocean? And a second part to that, will these benefits allow small island states like the Bahamas to become net energy exporters?
Yes and yes. To become affordable, we just have to build it. It's energy storage that once stored has no loss because it's in a controlled environment. You can build to scale to what the area needs or what your client needs in thousands of areas. You have enough area just within 100 miles of the United States in order to support the entire eastern seaboard with energy. So the affordable and cost effectiveness, especially because hydro is never affected by, pump storage hydro is not affected by inflation like the other energy storage technologies, and doesn't use specialized raw materials. And also we can build in those remote island areas in which the smaller islands, we can utilize that area and the people on it in order to, do O&M operations to help build the structure, and also to, just be there for future jobs and stuff like that. That gives the economy of the Bahamas an industry that is 10 times the size of your tourism in revenue. And if it would ever to be affected by a virus, somebody's going to have to explain that to me, because a virus wouldn't affect energy being exported from the Bahamas.
Very great points, Mark. Thank you. And the data and the numbers you use to support it is always helpful and appreciated.
Oh yeah,
thanks
absolutely.
So much for that. Captain Hutchinson, where do you see the biggest opportunities in the maritime space for Bahamians to participate?
Thank you, and that's a very good question. And now I say this with the caveat because I'm a regulator, so I'll just put that out there. But just something Mark just said that I think is the having the capacity and capability is going to be critical in order to support all the industry. There's no point saying we go have going to go into windshore and all these aspects. So I think in terms of opportunities, I think we first of all have to create the capacity capabilities in order to provide those opportunities. And I would say that the biggest opportunity is going to be in that logistic and service sector, that the supporting arm of the ships coming in, the supporting arm of all that renewable energy concept. But by building our internal capacity, by looking at education and particularly the STEM subject, we will make sure that we do develop and we do have in place the necessary engineers, the marine engineers, and all those other four sets of disciplines that will then lend itself so that Mark and his team don't have to bring foreigners or external parties to the country. They can draw it from the country. And definitely in my presentation, I talked about the regulatory framework. And it's also understanding how those ship to shore aspect interface. And you would see that a lot of that is dependent on capacity capability, but also understanding what is the regulatory framework that drives that. Because as much as Mark and Christopher, they mentioned, but investment, and having investment, you need the people to understand the outcome of those investment. You need the discipline and the professional who can then operate those. And then you're looking long term, and that's where certainly at the BMA we've been investing in. We have the Bahamas Maritime Cadet Corps, where we're looking to bring in the next generation of seafarers in order to operate the ships, in order to be involved in the financial ship finance, in order to be involved in ship designing those assets that Mark is talking about, in order to monitor the traffic coming through that some of the persons is doing. So yeah, I know that doesn't tie in any specific opportunities, but I think if you look at it from end to end, there's a number of variables in there that I think any entrepreneur can see. And then one other final tag that says that the Caribbean has got we call it Caribbean Technical Advisor, which is supported and funded through the International Maritime Organization. That is so the Caribbean Regional Advisor assists all the Caribbean countries in building capacity, and that's certainly something which we through the BMA, working with all our partners agencies, are capitalizing on all the support they're offering us so that we can have Bahamians up and ready for when the opportunities that Mark and Christopher talk about come to fruition.
Outstanding, Captain Hutchinson. Thank you very much. Your wisdom comes through in the things that you share, especially in that response. Everything from education, the need to shift our cultural approach to more STEM-based and inclusiveness, the need to train, the need to network, and of course, pulling in the information that Mark and Christopher would have already presented. Thank you very much for that outstanding, comprehensive response. Christopher, we'll go to you with the last set of questions. Then we'll have one more with Mark and Captain Hutchinson, and then we'll circle on to the audience-based questions. We still have just over 20 minutes, so we're good on time. Thank you, everyone, for doing your part with that. Christopher, what are the biggest challenges and opportunities emerging in the energy sector and the blue economy? And how is the sector growing in the Caribbean?
Thanks, Carlos. So I think the biggest challenge facing the renewable energy transition is the ease of doing business and the lack of enabling regulatory or legal frameworks. So, I mean, another one is also the availability of appropriate financing to really promote the development at scale, especially when we start talking around small scale distributed projects like in the residential space, for example. CDB, we've been very active in supporting capacity strengthening and promotion of informed decision-making at the various regulatory bodies to help unlock the potential for scale deployment of RE. I mean, the opportunity is clear. We have the resources to become completely energy independent and eventually even become net energy exporters. So energy independence needs to be, and energy security for that matter, needs to be a critical objective for the countries in the region. And I would say in order to achieve these goals, effective engagement of the private sector is also essential, either through public-private partnerships to enable large-scale development or through attractive frameworks to incentivize investment in the sector and engage with MSMEs. As far as the financing goes, you know, CDB and the other development partners have been working to deploy more and more concessional resources to support countries and governments in their energy sector transition. For example, from the likes of the international donors like the Green Climate Fund, which have special type of resources to particularly around climate mitigation and climate adaptation projects, especially in the RE space. So we're very, very optimistic. I think that the development in the region has been slow, but I think really momentum is building. Political will, I would not say, is an issue at all. I think that everyone recognizes that the energy transition is essential and that the potential for you know, security, resilience, and economic growth is really massive. So hope that gives some perspective. Thanks.
Yes, we appreciate that, Christopher, and we appreciate what you and your team at the CDB are also doing to help to facilitate those frameworks and to promote the much needed aspects of energy security through supporting our governments in our region in these initiatives. So we appreciate that. Mark, what other benefits can Bahamians expect from utilizing blue economy-based energy solutions? Things like desalination, hydroponic agricultural production, etc. You're muted, Mark. No problem.
Oh my gosh, sorry about that.
Lower you were muted the
yeah.
whole time for the last hour, unfortunately.
Oh darn.
We're joking.
Well, you'll have to fly me down, and we'll talk. On the
in person.
Yeah. Being serious, lower energy costs, cleaner water, more reliable water, and especially after 2019, we can see that the hurricanes are extremely destructive. What you guys went through there, but the fact is that the storm surge was probably the most devastating, especially with the brackish water, and the wiping out of your utilities and so forth. Building a renewable system, which then gets wiped out again by another hurricane because it's put in the wrong area in the storm surge, could be devastating. With the structures, you're dealing with many different advantages to having desalinated water for that local area, having a enclosed system which is controlled so that have I lost everyone?
No, you're good.
Okay, no, okay, just a second.
Hanging on every word, hanging on every word.
Oh, okay, yeah, sure, yeah. I probably have a few people asleep right now, so
we're captivated.
And so it also provides safety and security for the micro solution that is currently needed, but also in the macro solution globally. And just almost every industry can be supported by hydropower. Unfortunately, topography limits a lot of countries from having any kind of pump storage hydro. So, what this gives the Bahamians is something in which once you build it, its return on the investment is into the tens, if not hundreds of billions of dollars. So, spending $1.8 billion to power your island, New Providence, gives you a return of hundreds of billions of dollars over the coming years. And with other future technologies, we'll be able to really bring your nation into what you call the ocean nation.
Thank you, Mark. It definitely ties perfectly into the blue economy plan and outlook that's the purpose of this think tank. Appreciate that. Captain Hutchinson, from a regulatory standpoint, are we prepared to implement the innovative solutions within the blue economy, like those created by Mark and proposed by Christopher?
Are we prepared? Okay, in terms of from the ship perspective, I showed you in one of my slides, you saw that design of a ship that was shaped in a way that it was skewed and it was carrying the solar, the wind farm blades. But I would say that regulators are known for being slow. Let's put that up front. However, what the IMO has done is that you have 176 countries. We meet with industry groups, and you're trying to develop a common set of standards. So yes, that will take a long time. But one of the principles that we have developed is this idea of what we call a goal-based approach. Now, what does that mean? It means, in the case of Mark's development of a project that goes beyond what is the prescriptive nature of what's in the regulation, they do have a framework of guidelines that will allow administration regulators to say that, okay, the designs, the progress, the process they're looking to implement, does that meet the goal intended from a safety, security, environmental perspective. And if it does, that principle or that design is then agreed and accepted, even though it wouldn't be within the nature of the prescriptive regulation, that will still be being assessed and updated. So certainly the IMO, the International Maritime Organization, and member government have come a long way because they realize that technology is moving at a fast pace, and to get 176 countries, 50 industry groups to agree on one global standard will always take time. So I think the goal-based approach does give that scope for innovation. It also gives the scope for, and we've put in framework, and looking at some of the what was covered in this panel, that they also have guidelines covering areas such as environmental sustainability, covering areas such as that if Mark and his team wants to put, or there has been investment into putting wind farms or solar panels in certain area, there is a regulatory framework that talks about protection of particularly sensitive sea areas. There is a framework that would say that the Bahamas would do an assessment to look at the navigational routes through the Bahamas, as you saw in our area, and make sure that where those designs or those structures go does not interfere with the commercials route through it, and that would be agreed globally. It does take time to do the studies and put it in place, but like I say, by having that framework in place, I think it does allow for investors, innovators to come into the sector and say that we want to do this to help from an environmental safety or a security perspective. But the regulations say you have to do A, B, C, but I can demonstrate that I can achieve those goals by doing it this way. And therefore, it allows those, whether it's a design to be implemented on board a ship, whether it's a process to be introduced by a company, or whether it's the training of personnel that do come into play. So yes, I think we have made strides to be able to allow for sort of innovation and thinking. Because let's face it, I think where the world where we are now compared to where we are, say, 25 years ago, even 1 year ago, is that technology has pushed us up along the digitalization and other platforms that we have to embrace in the ongoing development. And I think as regulators, we may be slow, but we get there in the end, and we try to put framework to future proof. But it's always a challenge trying to future proof anything. But I hope that answers your questions, and I look forward to any other questions that may come from the audience. Thank you.
Thank you, Captain Hutchinson, and thank you so much for your feedback from the panelists. We will now go to some of the questions. We have about 12 minutes or so left in our time, so we'll ask for your responses to be as brief as possible so we can get through as many as possible. The first one is for Captain Hutchinson. What are the 3 most strategic implementation of regulations, or which regulations are put in place to prevent dumping of all of these ships that are passing around and through the Bahamas?
I wouldn't say free. Well, let's back up a bit. When you say dumping, I think the first thing to say is that ships operating globally have a standards they have to comply with in terms of marine environment protection. On the slide, I talk about the MAPL International Convention for the Pollution by Sea. And there are different annexes covering oil, sewage, garbage, noxious liquids, noxious substance, air emissions, so 1 to 6. So within those framework, that sets the standard for how the ships are supposed to operate, what equipment is going to be on board, what is going to be, how it's approved, and that standard applies globally if you are operating anywhere. And that is what the Bahamas does. That is what the Bahamas applies. The concept, as you said, dumping. Well, first of all, I say that there's what we call discharges, and there's permissible discharges within the framework of the convention, and there's areas where there may be non-compliant discharges. And I think the issue is determining through a proper investigation whether, if there are discharges, was it in line with the international standards as adopted by the Bahamas? If it was, we moved, well, that would be there. And then B, if it is deemed to be that it wasn't in line, then you have to obviously undertake a different tack in terms of how do you enforce and what penalties you give to the operators. So whilst it's not, I wouldn't say it's free, there are clear guidelines, clear standards applicable to MARPO discharges globally. And the Bahamas is a signatory to those conventions, apply those standards. Thank you.
Thank you very much, Captain Hutchinson. Our next question from Michael is, hi, Christopher. Given some countries' ongoing developments in the oil and gas sector, example, Guyana and Trinidad, does the CDB see potential areas and benefits for integrating the blue economy concept within the existing policy framework governing the exploitation of oil and gas resources? And can these policy interventions realize sustainable exploitation of these resources to meet the tenets of blue growth? So I can, I guess, summarize that if you need, Christopher, if you got it, go for it, please.
Yeah, what a question. I mean, it's an excellent question. It's excellent consideration. I mean, strictly speaking, we could consider all kind of marine industry as blue economy, right? So while we wouldn't consider it to be, I guess, renewable or sustainable development, the fact remains that these countries have these resources, and it's an important part of their economic structure. As it pertains to embedding the new type of policies that would be required to govern other blue economy activities within the existing framework, I'm not sure if that's the most appropriate way. Maybe it is. Certainly we can learn a bit about what has been done to manage that type of activity in the blue economy space in the past and see what fits. For example, the seabed leasing and block bidding on areas for development for marine renewable energy, such as wind, for example, could be something that we take from the oil and gas industry in the past. There's no point inventing wheels. So I would be, I would suggest assessing what makes the most sense with what has been done before and applying where is appropriate. That's all.
Sure. Thank you for that, Christopher. And you have a few other questions that sort of tie into that from Michael as well. As seen in the North Sea region, the transition from oil and gas to include offshore renewables into its blue growth framework as a key example for the Caribbean region. Do you see similar approaches? And then what about the Great Bahama Bank site, which was another question. So I guess one, are we sort of looking at what was done in the North Sea as applicable for the Caribbean? And then two, what about the prospect of the Great Bahama Bank site?
Yeah, definitely taking examples from who's done it before is the order of the day. As I said, no point in reinventing the wheel. That being said, there's quite a bit of nuance around the Caribbean, especially when it comes to energy. Small island development states with very small grids, we can't really just plug and play a significant capacity of variable renewable energies like they can in larger countries. So we had discussions with certain consultants who had done work in the North Sea and in the UK around how they were approaching the rights for development, the leasing, how they selected who would get to develop it, how they were deploying financing, how they were handling social and environmental impacts, that type of thing. So we are seeking to learn as much lessons from who's done it, not just in the North Sea, but there are other areas in the world who are a few steps ahead when it comes to marine renewable energy development. And I must be honest, I'm not quite familiar with the Bahama Banks site. I don't know if you could give a bit more context on that one.
Yeah, so the Great Bahama Banks on the outside of Andros, it wrapped around up towards Grand Bahama. A part of your area did cover it. It sort of borders between us and Cuba and Florida. So it was a part of your study as well.
Thanks.
Helpful. All right. We have a few more for you, Christopher, but I'll jump one over to Mark out of the other chat. Mark, what does your company do to mitigate from the potential damage of hurricanes?
Well, the structure is out of the water to a significant degree, and it's made of concrete. It's a gravity-based structure, so it's extremely strong. There would be damage. Wind, like if it's blowing a Volvo and it hits the structure, things are going to get damaged. Would there be an extensive loss of life? Probably not, because we could have everything sort of behind concrete, but basic replaceable materials could be easily just repaired in the future.
All right, thank you for that, Mark. Which would he consider, I presume this is for Christopher, more applicable to the Bahamas? Is it wind technology or solar? And also, has the CDB conducted a study for solar energy as a renewable? I know you did speak to that briefly, Christopher. Maybe you can just answer that.
Yeah, I mean, I think solar is generally considered, especially for our region, when we look at the solar resource, to be the lowest hanging fruit. But I would say that, again, talking about small islands, grids, that we really do need a diverse array of generating technologies, renewable energy technologies to ensure reliability, resilience, and whatnot. So that would be solar, a combination of solar, wind, storage, and whatever else resource you have. Some countries have biomass, some countries have geothermal, and what have you. But generally, that's best done in the context of an inclusive and engaging plan, such as an integrated resource and resilience plan, which I believe is either ongoing or in the pipeline for Bahamas, which would work with all stakeholders, the utility, the government, the energy ministry, etc., to determine what the generation mix is going forward, what the potential demand is going forward, and then you would use that to guide what technologies you would seek to promote or incentivize.
Sure, thanks for that, Christopher. And this next question seems to be for you, and the last two appear to be for Mark. So Mark, you can get ready. What is the estimated cost of one wind turbine and the cost of maintenance per year?
I actually don't know that. I saw that one in the chat, so I apologize. I would have to do a bit more research, because we would be looking at project level financing. So when you break it down to that level, I'm not too sure, especially when you talk about offshore wind. You're usually talking about projects in the 50 to 100 megawatt type range. So as you imagine, that's several turbines. So the individual turbine level, I'm not familiar with those figures.
Sure, thank you for that, though, Christopher. Jensen asked, how many of the structures can be used to make the need for carbon-based energy obsolete in the Bahamas? Mark?
10, 50 megawatt structures.
Okay.
500 megawatts, you guys become zero net emissions.
And what's, just a question of mine, what's the lead time on those structures in terms of having them available?
From now to, building a 50 megawatt, because a lot of it now can be prefabricated. So structures can go up pretty darn quick, especially once we've got the materials already built and stuff like that. The first one would take a little longer, but the second and third one would be within a year. Okay. These things can go up very fast, and especially like I said, advanced engineering, building. Countries like Dubai and China have shown that we can build exceptionally high and exceptionally quick.
Excellent. And can a floating dock or platform, or even a boat with solar power capabilities and wind harness capabilities be constructed and simply be moved to a safer area in the event of a hurricane? So are there any type of floating platforms that can be built?
Yes. Yeah.
Okay. Great.
And they're also designed too to be like if they have an extensive amount of tonnage, like some of these things will weigh like 8,000 tons, 1,200 tons. So, once you secure it to a seafloor, which can also have, sort of special anchors put into the ocean. And yeah, as long as you're not out in the open ocean during a hurricane, yeah, you're pretty much going to be safe.
Excellent. Great. Thank you very much. So to our panel, that covers our questions. It is now 2:20. Our scheduled time was to end at 2:20. Congratulations. We appreciate our entire audience, the participation, the feedback, the questions. Thank you so much to participating in this think tank. We are grateful that you all shared your time and expertise. And for the attentive audience who had a number of questions, I see you have the emails and the contacts for most of the panelists. So feel free to get the quotes for whatever you need, set up a wind farm in your backyard or an entire energy sector. And of course, we appreciate Captain Hutchinson and what he and his team continue to do as it relates to our regulations. So once again, I'm Carlos Palacios. I appreciate you participating here. Congratulations to the Bahamas Development Bank, to Samaya Page and the team, and wish you a wonderful afternoon. Be safe and take care. Thank you.
Thank you.
Thank you very much, everyone.
Thank you very much. Thank you.
Okay.
Thank you, Carlos. We will have a short intermissive of about 5 minutes before our next segment starts.